This test takes 5 seconds to run on good computer. It boots Spring, it starts an embedded database, it loads your entire application context, and all it is actually doing is checking whether a user with a duplicate email gets rejected. This one runs in 15 milliseconds. Same logic, same assertion, no Spring, no database. In episode 1, I show you a project structure that separates API, domain and infrastructure. That was good. Today we are going one level further. And the difference is these two tests. This is hexagonal architecture. And by the end of this video, you will understand not just what it is, but exactly how to implement it in Spring Boot and why your existing structure is already closer than you think. From episode 1 and show you what is missing. Here is our user controller. It calls user service directly. Fine so far. Here is user service. It calls user repository. Also fine, but look at what user service actually does. It is doing three things. 1. It validates business rules. 2. Orchestrates the flow. Load user, apply rule, save user. 3. It decides when to send an email from here. That is all in one class, and that class is annotated with annotation service. It already has a Spring dependency. Here is the problem. In episode 1, the structure looks like this. So controller calls directly user service with annotation service, user service call user repository interface, and user repository extends user JPI repository. There is no explicit contract between the controller and the business logic. The controller knows about user service, a concentrate class. If tomorrow you want to expose the same logic via a Kafka consumer or a scheduled job, you have to duplicate the call or inject the same service everywhere. More importantly, there is no way to test the business logic without Spring. User service depends on user repository, which is a Spring data interface. To test it, you either load the context or mock with mock-bin. Both are slow. What is missing is one layer, the application layer. Hexagonal architecture was invented by Alistair Cockburn in 2005. The core idea is simple. Your application is a hexagon. The outside world connects to it only through ports. The hexagon contains two things. Your domain, value objects, domain rules, and your application, use cases that orchestrate the domain. Outside the hexagon are adapters, anything that connects the outside world to your application. A REST controller is an adapter here. A JPA repository implementation is an adapter. A Kafka consumer is an adapter. A scheduled job is an adapter. The rule is absolute. Dependencies point inward. Nothing inside the hexagon can import anything outside. This is why the test speeds differ. When your business logic doesn't depend on Spring, JPA or HTTP, you can test it with plain Java. No context loading, no database, just code and assertions. Episode 1 got you 70% of the way there. You already have domain isolated. What you are missing are ports. The former interface that define what the application can do, what it needs from the outside world. There are two kinds of ports. Inbound ports, also called driving ports, define what your application can do. They are the API of your use cases. In Spring Boot, there are interfaces that live in application port in structure. Outbound ports, also called driven ports, define what your application needs. They are the interfaces your domain uses to communicate with the outside world. Save use port, load use port, send welcome email port. This live in application port out. Let me sort our structure. So In the user package, because we have order package too, we can create the application package, create here the port in and out, and of course service. Okay, now we can create the adapter. You have also in and out, and we can create here the web package and put our everything from API. So here, now we can delete our API folder. In our adapter out, create another package persistence, and here we can put our user JPA entity in persistence here, and user JPA repository too. And we can put user mapper. Now we can delete. We still has our user repository and our user service. Let's create our first inbound port. This is the use case interface. So we have create user, so just create interface, for example, register user. We create this in application port in. So create register user. And now we don't use our user entity. We use user from our domain here, and we name it register. And now we don't use user request because it's the HTTP layer. So we use command. For example, we name it register user command. And now let's create register user command. This can be in our application port in package. It will be record. Now we can put string name, string email. We can also add validation. For example, we can use a compact constructor here. So if email is null or email does not contains, for example, show new illegal argument exception, invalid email, and here we can use name. If name is null or is empty, it's blank, you can illegal argument exception, invalid name. Okay, so now if we create this object, we cannot create wrong object. So validation it's here. Now let's create the outbound ports. These are the interfaces that tell Spring I need something from the outside world, but I don't care how it works. Let's create in our out package free interface. So now load user port. Which one? Response user, load user, user ID, user ID. So let's create another one. Save user port, user save user. And another one, so check user email exist port for example. Notice the names. Not find by ID, that is a database concept. Load user, that is a business concept. This naming distinction matters because ports should describe what the business needs, not how the technology works. So now let's move to our web controller. So we use user service here. So now we can use our register user from here. So now we can, instead of user service, we do it like this. So register user command, we create register user command. So we take it from our user request, its name and email. Okay. If we have our command, we get user register and send our command. So now we can we have user response. So now we can add function public, make it static. So now user response from user. No, it's okay. Okay, now we can comment this right now. So now the controller depends on the register user interface. It has no idea what class implements it. It doesn't care. That is the board. So now let's create the outbound adapter, JPI persistence. So this one we create here, user persistence adapter. This adapter has component annotation of required args constructor, and we implements all of our out application ports. So load user port, save user port, and check user email exist port. And now we can implement all of this method. Now we can use our user JPA repository from here. So now like that. Okay, now I show you user entity. So we have annotation entity. This is in our database, but our user is our domain object. So okay, I forgot put return. Okay, so now we have our user persistence adapter. So it's okay. Now what we need is create the application service that implements the use cases. For our example is it is a register user. So now let's create service, register user service. Now we implement the register user. Yes, from here. So let's implement register method. So now we can inject check user email exist port. Now save user port. Let's implement our function. So check is our email exist. So command email, new email, because we have a value object here. We can also create own exception. So let's create new user. We use domain object. So user. Let's create the public static function names user create. We put string email, string name. return. So we don't have a generate function. We can null in ID. So let's create email command get command email command name. So now we can use save user port, put save, and put our new user. Look at what register user service depends on. Two interfaces, check user email exist port and save user port. That is it. No user repository, no Spring Data, no JPA, no HTTP, pure Java. It implements a register user, the inbound port. The controller doesn't know this class exists. It uses save user port, the outbound port. The JPA adapter doesn't know this service exists. The service sits in the middle, knowing about neither the top nor the bottom, only about the domain and the port interfaces. Spring dependency injection does the writing automatically. When user controller asks for register user, Spring looks for a annotation component that implements it, finds a register user service and inject it. That is the entire mechanism of hexagonal architecture in Spring. You have been doing it all along. Before test our application, just clean up our structure. We don't need any more user repository and user service. We put value objects to to shared package, but you can put value objects to the domain and exceptions too. You can create another package named exception. Okay, now is the moment that justifies everything. Here is how we tested this in episode 1. So we have here annotation Spring Boot test. It's run Spring Boot context. So we're just waiting for Spring Boot context. Okay, test was very fast, but we need to run the Spring Boot context. I simulate this time using this configuration with post construct. You can easily delay this. Okay, and here is the same test with hexagonal architecture. So now we can run and it's done. No annotation Spring Boot test, no Mockito bin, no context loading, just a class. It's dependencies injected in the constructor and the test. If your build has 200 tests like the first one, that is potentially 2 hours of build time eliminated. This is not a theoretical benefit. Every senior developer I know has fought this problem. Before we wrap up, I want to run a little contest. Everything we built in this episode, ports, adapters, the package structure, is something you can apply to your own Spring Boot project right now. So let us make it interesting. Take Spring Boot application from the description and refactor it to hexagonal architecture. Open a merge request on this repo. Create load user, we comment it here in user controller, and refactor other package from here with hexagonal architecture. Give subscription and rate this film. What do you like about it and what could be improved, and drop your GitLab username in the comments below. And I will pick one random winner from everyone who submits before the deadline. The prize? Get your hands dirty on Clean Architecture by Tom Homberg as an ebook. It is the book that popularized this exact pattern in the Java world, and it goes a lot deeper than what we covered today. Deadline 2 weeks from today. Link in the description with all the details. What make a good submission? 3 things. Port have business names, not find by ID but load user. The domain package has 0 Spring annotations. And at least one test that runs without the Spring context. That is it. Drop the comment below. One honest section when this is overkill. Don't use hexagonal architecture for pure CRUD services if your entire service is safe, low, delayed, with no real business logic, separate entities and ports at boilerplate with zero benefit. Use episode 1's simpler structure, MVPs and prototypes. The first version of anything should be as simple as possible. Evolve toward hexagonal when complexity justifies it. Team without buy-in. A hexagonal codebase maintained by the developers who don't understand the pattern is worse than a well-maintained layered architecture. Structure requires shared understanding. The signal that tells you it's time. You can no longer add a feature without touching 3 layers at once, or you are afraid to test the business logic because it requires the full context. That is when hexagonal pays off. We took the structure from episode 1 and make it proper. Explicit ports, explicit use cases, adapters that know nothing about the domain, the core insight. Spring is dependency injection already does hexagonal architecture. You inject interfaces, Spring provides implementations. Hexagonal just means being intentional about which interface go where and keeping the domain completely free of framework annotations. Next episode? Value objects. This will be one of many introductory videos to DDD. Source code on GitLab, link in the description. Subscribe if you want to see the full series. See you next time.